Okay, so here we're going to build on our work from the last lesson, and we are going to investigate inflection points and this idea of concavity analytically. So we have this idea from the last lesson that an inflection point occurs at a min or a max of f prime. So remember, an inflection point is where a function changes from being concave up to concave down. So what this would look like would be something like this, maybe, right? So an inflection point would be here. So notice my function opens down to the left and then opens up to the right. Okay? And we have this idea that it occurs at a min or a max of f prime. So that's the derivative of f. So what we can actually do here is we can use f double prime to find inflection points. So we're going to use the second derivative in this lesson. And what we want, if we want a min or a max of f prime, is f double prime to change signs. Okay, so we're going to look for critical values of the second derivative and then check to see whether they change signs or not. Okay, my derivative of f is going to be f prime of x. I'm just going to use power rule, right? 4, 6x to the third minus 6x squared minus 14x. And then my second derivative is going to be the derivative of that, which is 3 times 4 sixths is going to be 2x squared minus 12x minus 14. Okay, so there is my second derivative of f. And my next move now is going to be to set that function equal to 0 to find my inflection points. So these are, we're looking for critical values of f prime, or sorry, f double prime I should say. And then I factor. So this begins to look like previous lessons, right? And what do I get here? I get x minus 7 times x plus 1 equal to 0. And then of course I get x equals 7 and x equals a negative 1 are my critical values. And then I'm going to draw a sign chart. And negative 1 is going to be to the left, 7 is going to be to the right. And I want to check my values here. So over here I'll plug in negative 2. Remember, I'm going to use my factored form. So negative 2, and you get to the point where you don't really need to do all of the math here, right? So negative 2 would be 2 times a negative number, right? Because we're doing negative 2 minus negative 7. So positive times a negative, and then negative 2 plus 1 is another negative, right? So this is going to be a positive region on the sign chart. Remember, you can always do these on your graphing calculator too. Then here I'm going to plug in 0, so I get positive, negative, positive. So positive times a positive is going to be negative. And then over here I'll plug in 8. So I'll do positive, positive, positive if I plug in 8. So we are looking for values where f double prime changes signs. Well, it looks like it's both of our critical values, right? So my final answer here would be x equals 7 and x equals a negative 1. Okay. And I would encourage you, so remember our original function is up here. I would encourage you to pause and graph that original function on something like Desmos or your calculator and take a look at what it looks like at these points. So we should see changes in concavity at these points. Something like this. Okay. Make sure you got that before we move on. All we're adding is the second derivative, otherwise this is very similar to what we've done in previous lessons. Okay, let's try a couple other ones. So now this one's a little different. So we are looking for intervals where f is concave up. Well, concave up would look something like this. So concave up means the function's increasing at an increasing rate. So increasing at an increasing rate, right? What that means is the derivative of the derivative is positive. So concave up means that my second derivative is positive, is what I'm looking for. Okay. So we'll start by finding the derivative. By the way, I will give you a cheat sheet with all of these facts, such as concave up means that the second derivative is positive at the end of the lesson here. My derivative is going to be 5 times negative 3/5 is negative 3x to the 4th plus 28x to the 3rd. Then my second derivative going to be negative 12x to the 3rd plus, let's see, 3 times 28 would be 84x squared. Okay, so there's my second derivative. I'm going to set it equal to 0 because I'm looking for critical points. And I'm going to factor out my 12x squared. Negative 12x squared is what I can factor out. So I'm left with just positive x, and then negative 12x squared, I divide it into this term, I get negative 7. Okay, so there's my factored form. I'm going to set each factor equal to 0. And of course I get x equals 0 here and x equals 7 here. So these are my critical points. And I want to see what is happening between them, right? So these are the boundaries of my potential regions of concavity here. So I have 0 and 7 are my solutions. And then I want to check each region. So let's see, when I plug in a negative number, negative 12x squared is always going to be negative because the x squared, right, gets rid of any negative signs we plug in there. So I have negative times another negative is a positive in that first region. I'll plug in 1 for my middle region here. So again, negative 12 times negative 6 would be another positive number, right? And then my last region, I'll plug in 8 and some big negative number I get here, 12 times 64. And then 8 minus 7 is positive 1. So negative times a positive is a negative. Okay. So there's my sign chart. Remember, this is for f double prime. And what we want is for f double prime to be positive, we said. So here we'd say f is concave up on, not 0, negative infinity, we'd say, to 7. Okay. Then we'd say it's concave down above 7. And again, if you would like, it's a good exercise to graph this one on your calculator, see what it looks like. We'll do one more. This is going to be really similar. Now we want concave down. And if you're like, well, concave up means second derivative is positive, concave down must mean second derivative is negative, right? You're right. So I'm going to take my derivative. So f prime of x is going to be x to the 3rd minus 6x squared minus 48 times 2 is 96x. So there's my my derivative. I'm going to take the second derivative here. So f prime becomes f double prime, and I get 3x squared minus 12x minus 96. I'm going to set it equal to 0 and find my critical points. Notice I can factor out a 3 to start. So I'll get x squared minus 4x minus, what does that give me, 32. Then I'll continue to factor. I think many of you can do it this fast. Feel free to pause if I'm doing the algebra too fast though. So there's my factored form. And I get x equals 8 and x equals negative 4. When I set those equal to 0, I'm going to draw my sign chart. So we have 4 and 8 are our boundaries, are our critical points, and it's a -4, I should say, right? So I'll check value in the left here, and let's see, we'll use just -5. So that's a positive number times, this would be -13, so times a negative number times another negative number. So positive times a negative will give me a positive result. In the middle here, 0 is part of this interval, so I'll do 3 times 0 minus 8 is -8, 0 plus 4 is 4. So positive times a positive would give me a negative result in the middle. And then over here, let's see, I'll use 9, so 3 times 1, +1, and then times +13, so all 3 positives give me a positive result. So there's my sign chart. Remember, we are looking for concave down intervals, so we're looking for the negative region of my sign chart. So here, I'd say f is concave down on the interval -4 to 8. Okay. So I'm going to end the video with a little table of our conclusions here that you can capture in your notes. Make sure you grab that before you move on, and then feel free to jump into the practice.